And now we would like to know where you are from. Please write in the chat which country and city you are from, please.
Yes, very interesting to see the geography of our webinar.
Moscow, Russia,
Moscow,
great.
Russia, interesting. We are from Russia.
Philippines, cool.
Philippines, great.
China, Queen. Wow, I don't even know this city. So Austria, Vienna, Lima, Peru, South Africa,
Nairobi,
Kenya. Wow, it must be quite hot in these countries.
Romania, Philippines, Dubai, India, Turkey, great.
Philippines,
Again,
Germany, great.
Great.
Romania. A lot of people from Philippines, I can see. Switzerland.
Taiwan.
Philippines, but working in Maldives, great. India.
Okay, I think we can start our official part of the webinar. My name is Sergey. I'm editor-in-chief of website refrigeration industry. I want to introduce my colleague Vanessa. Vanessa will be the host of our webinar. I'm happy to welcome her.
Good morning or good afternoon. It depends on where you are. My name is Vanessa. Thanks for introducing me, Sergey. It's nice to see you. I'm happy to be here. So what are we talking about today?
Today we are talking about latest product innovation, new solution for refrigeration, and new care opportunities.
So we will shortly tell you what the webinar is going to be about, the order, the agenda of the webinar, and then we will introduce our wonderful speakers. I give the word to Sergey.
Thank you very much, Vanessa. Dear friends, we will celebrate World Refrigeration Day on June 26th. World Refrigeration Day serves as a means of raising understanding to the general public of the scientific role that the refrigeration, air conditioning, and heat pumps industry and technology play in the modern life. Hope our event today will contribute to the achievement of the goal. Let me congratulate all of those present on this momentous occasion. And please subscribe to our website to stay up to date of refrigeration industry. Please find the link in the chat. One moment, I will share a link in the chat.
Okay, great. So
we wait you on our website every day.
Yes, yes, you can see the link. Please check this website. So I want to remind our audience that you can ask questions. It's very good. If you ask questions, please ask questions after each presentation. Be active because we will draw prizes among those who makes the most interesting questions.
One more, please read in the chat how to ask the question, for example.
Yes, so you can see how to ask the question. So I can introduce the speakers?
Yes.
Okay, great. So I'm very happy to introduce you. Our first speaker is Didier Coulomb, the Director General of the International Institute of Refrigeration.
Didier, please tell us some word.
Okay, thank you very much. First, I would like to thank the refrigeration industry for having organized.
Sorry, Didier, we will introduce all speakers, okay? And
okay, sorry.
will start. Please, one moment.
So our second speaker will be Volker Stamer, Director of the International BITZER Training Center, SCHAUFLER Academy. And
Good morning, everyone.
Yes.
Good morning.
Good morning. And our third speaker is Nikolay Koev, Sales Manager East Europe at Sanhua International Europe.
Hello, everyone. Very nice to be here and to have this opportunity to introduce company Sanhua and our technologies. Thank you for the organizations to Refrigeration Industry Media.
Great, thank you.
Okay.
So then we're ready to start. Now, Didier, please, I'm happy to pass on the word to you.
Thank you. So once again, I would like to thank all of you from all over the world. So good morning, good afternoon. And I would like to thank Refrigeration Industry for having organized this webinar. It is effectively almost the World Refrigeration Day, so we have to promote refrigeration. It is also, and it will be one of my conclusions, the day of the women engineers, and because I think that we have to promote it, especially for having more women involved in the refrigeration industry. So, I would like first to introduce the International Institute of Refrigeration, a few words about what we are doing in all your countries. Secondly, to present three main challenges. We have main challenges within the industry, so it is important to mention them and to involve more people. We have increasing needs, we have food and health, and we have climate change. And so my conclusion will be to attract more people for the industry. A few words about us. We have all the fields, all the technologies, all the uses of refrigeration which are present in our organization. Cryogenics and liquefied gases, thermodynamics, equipment and systems, biology and food technology, storage and transport, air conditioning, heat pumps, energy recovery. So we cover all these fields, and even if they are various, they have a lot of common challenges, especially refrigerants, energy consumption, health. So it is important to have the possibility to cross all these fields. We are trying to be in connection with the Sustainable Development Goals of the United Nations. Clearly, all our actions are more or less linked with one of several Sustainable Development Goals of the United Nations. Key domains of our activities include food quality and safety from farm to consumer, comfort in homes and commercial buildings, healthcare products and services, low temperature and liquefied gas technologies, and of course, energy efficiency and the safe use of non-ozone depleting and low global warming refrigerants. We have an international network with 59 member countries in all the continents, not all the countries you are, but perhaps in the future, I hope that all of you will be able to be part of our member countries. We have corporate and private members from the industry, universities, consultants, students, and we have experts all over the world in all our member countries in all the fields I mentioned before. And you have here also on the bottom the various organizations we have partnership with. So we are intergovernmental. It means that we have a general agreement within all these member countries, 59 member countries, and because we are intergovernmental, we of course have a lot of links with other intergovernmental organizations, especially United Nations. But we also have private people. So our services, our aim is to disseminate information on all technologies and users. So we collect information. We have a freedom database with more than 110,000 articles. We publish guides. We have reference documents such as the International Dictionary of Refrigeration. We have a scientific journal, the International Journal of Refrigeration. We publish informatory notes for decision makers. We have directories, expertise directories, laboratory directories. We organize a lot of various conferences in our various member countries. We have working groups in lot of various subjects, and we are part of various research and development projects, especially in Europe, but also in developing countries, in partnership with various organizations, particularly some developed countries, the United Nations, and so on, because we have to implement a sustainable refrigeration everywhere in the world. So we are part of these research and development projects. First, what are the challenges? The increasing needs. We have increasing needs in refrigeration users. Food, health products, air conditioning, heat pumps, liquefied gases, cryotherapy, information technologies, biotechnologies, space industry, steel industry, carbon capture and storage. So you see that refrigeration is everywhere. Even if it is not always visible, refrigeration is everywhere, and all these industries, all the day life, all your daily life is more or less impacted by our refrigeration industry. And we have an informative note, you can consult it. It is free of charge, the economy, refrigeration worldwide economy. So you will have a lot of figures. I will not detail them, but I would like to mention that for all the industry, classic, traditional industry, as well as the new industries, we need refrigeration. And secondly, refrigeration equipment per inhabitant, including the cold chain for food and health products and air conditioning, is currently far below in developing countries compared to developed countries. So in any case, we will have more development in these developing countries and thus more refrigeration equipment. We have increasing populations in addition in these developing countries. The people are more urban and more rich, and thus they have more needs, more refrigeration needs, more refrigeration capacities. So they will need more equipment. And once again, you can have a lot of figures in our website, for instance. So because of these two reasons, refrigeration is everywhere, including in the new technologies, such as, for instance, information technologies. And secondly, because we have increasing needs, especially in developing countries, we will have more and more equipment needs, more and more people needs. Secondly, I would like to insist about food and health. Food and health are, of course, vital for everybody. Food losses are huge due to a poor cold chain, especially in developing countries. Currently, about 800 million people are undernourished, and we will have to feed 2 billion people more because of the increasing population in these developing countries. Eliminating food losses due to a poor cold chain could feed up to 950 million people, according to our figures. And once again, you can see all the details. It represents about 1/3 of the needs for the middle of the century. So, and in addition, it is much better to have a refrigeration cold chain than using more water, more soils in order to be able to feed all these people. So it is necessary. Comparing an extended cold chain in developing countries, similar to the current cold chain in developed countries per inhabitant, would reduce the carbon footprint by about 50% compared to the current situation. So, of course, when you have refrigeration technologies, you will consume energy. You will use refrigerants, which are sometimes potent greenhouse gases. But in any case, even if the cold chain is not perfect in developed countries, even if the current cold chain, which is not perfect, it is much better to have a cold chain for food and compared to having no cold chain and to have food losses. In addition, the cold chain is also necessary for vaccines, for instance. Unfortunately, all over the world, for instance, you currently have COVID, and because of the COVID, we need vaccines all over the world. We will publish soon an informative note for developing countries in French, English, Spanish regarding vaccines. We need also refrigeration technologies for vaccines, and currently you have in these countries about 40% of the vaccines which are not properly stored, and those which are dangerous and shall be destroyed. It is, of course, a problem, a very important problem for all the countries, especially developing countries. Third challenge, climate change. Climate change is one of the main challenges for the world, and we are particularly concerned by climate change. Refrigeration, including cold chain, air conditioning, cryogenics, heat pumps, represent 7.8% in CO2 equivalent of global greenhouse gases emissions. It is our figures from, it was 4 years ago. We are currently updating these figures, but in any case, it will be at least the same figures or more than that because of the development of refrigeration technologies all over the world, in all technology, in all users. Within these 7.8%, you have 37% which are due to refrigeration emissions and 63% due to energy consumption. And it is not negligible regarding the energy consumption. Refrigeration represents about 20% of worldwide electricity consumption, according to our latest estimations. 20% of the worldwide electricity consumption, it means that you cannot have an energy policy without thinking refrigeration, air conditioning, and so on. It's not possible now. You have to take into account in all our strategies, state strategies, company strategies. And of course, the refrigeration issue with the Montreal Protocol, with the Kigali Amendment, I will not go into detail, but I suppose that all of you know these international agreement, the Paris Agreement regarding climate change. We will have in Glasgow at the end of the year, the next conference of the parties. The IR will be present because, and I'm sure that refrigeration will be discussed in Glasgow. We are preparing with the United Nations some statements, some decisions regarding the role of refrigeration regarding climate change. And we absolutely need to now implement actions on these topics at national levels. So at an international level, we already have the Montreal Protocol, the Kigali Amendment, the Paris Agreement. We already have some measures such as energy efficiency, renewable energy. We have to reduce the carbon footprint of the cold chain, of air conditioning especially. But the objectives at an international level must now be implemented in nationally determined contributions to be presented in Glasgow. In Glasgow, all the countries will present their national goals, the way they will obtain these results, and refrigeration shall be part of these nationally determined contributions. So, as a conclusion, I would like to insist on the fact that we need to attract more people, particularly women, because unfortunately we have a few women, and of course I'm sure that here it is the case, but it is certainly a source of people, not only a problem of equity between men and women, but a need, because we have increasing needs. We have to improve the qualification of the people because of the technologies which are constantly improved. We have innovations because of environmental constraints. We have to motivate people to explain to everybody, including people at school, that refrigeration is the heart of sustainable development. It is at the heart of the two main worldwide challenges in this century, health and environment. So if you have to deliver the message, if you would like to be really useful for the century, if you would like to have a role for the world, you have to work in the refrigeration field. And of course, the IR can help you to do that. We have an international network. You can become an IR member in order to have the possibility to benefit from all our services. You can see all the information on our website. And Of course, we can participate to all our events. I mentioned a lot of conferences. We have also a congress with all the users and technologies in refrigeration users. And so you have this picture from Paris. I'm in Paris. So I would like to thank you, and I hope that this webinar will help you to better promote the refrigeration industry. Thank you.
Great. Thank you very much, Didier.
Thank you. Yes, thanks for your presentation. So we are waiting for your questions, dear audience.
I ask first question. Didier, from which countries can companies and the people become members of your organization?
Well, we have first member countries. We are intermental, so we have 59 member countries. Most countries in Europe, the big countries such as China or India, Russia, United States, Canada, and so on, Australia. We have some developing countries in Africa, in Arab countries, in Sub-Saharan African countries, few countries in Latin America. In any case, you have the list of our member countries in our website. I can give you the list, but time. In any case, even if you, and of course, if you have some connections with governments, it would be fine to have more countries. However, even if you are not in a member country, a company or university can be a corporate member. It is also the case in developed countries, but not with the same price. Of course, it is much lower in paying member countries. But if you are an individual, if you are a company, if you are a university, even in developing countries, in not member countries, you can participate, you can receive all our services. You can participate to our working groups. There is no problem. We'd be pleased to do it, to welcome you. The only problem is, of course, that you don't have any vote, you don't have any possibility to influence our policy. But we welcome everybody.
Great. We have some questions.
Yes, a moment. Vanessa, please find the question mark. Anthony Young.
Okay, yes. So, question for you, Didier. Looking at the whole refrigeration chain, which part or parts do you think have most potential for improvements regarding the future targets of energy savings?
Well, I think sincerely that we have possibilities in all the technologies. Currently, our main target is air conditioning, because air conditioning is fast developing in all the countries. And of course, climate change will increase also this need because there will be more heat waves, for instance, including in countries where it is not absolutely necessary now. And if you compare the efficiency, the energy efficiency of the various air conditioners, including the small ones, you have a lot of possibilities. You have a difference, so important difference between the best and the worst equipment, that in any case we have a lot of possibilities to improve the efficiency in trying to make some labels for the good ones, to perhaps prevent people to buy some kinds of equipment, to improve the technologies. So it is, in my opinion, the first place we could act. Of course, because the first use for refrigeration is the cold chain for food and health products, of course, we also have a lot of possibilities for instance, domestic refrigerators and so on. But if I would like to give you a main target, I would cite the air conditioning.
Great,
Okay.
thanks.
Next question from Mattis van der Wol. Didier, what's your opinion about standardization of refrigerants?
The evolution of refrigerants. Well, in the long-term perspective, I'm convinced that except for very limited applications, you will have very low global refrigerants everywhere, in almost all the users, all the applications. So as far as it's possible, if it is possible, please go directly to very low global refrigerants. I mean natural refrigerants such as ammonia, CO2, hydrocarbons, sometimes air or water. Sometimes you can have some synthetic refrigerants, low global potential HFCs or HFOs, but well, with some perhaps other constraints, and I think that the share of natural refrigerants will increase. But in any case, if it is possible, please do it. But it is not possible to change all the equipment now. If you have relatively new equipment, it is better to have, well, intermediate refrigerants. And you have a lot of various intermediate refrigerants which are developed by various companies all over the world. So they are not the best ones. They are better than the current ones, current HFCs, current HCFCs. But for a few years, it could be fine. But please also think about a long-term perspective. And for me, in any case, if you see, for instance, the Kigali Amendment of the Montreal Protocol, the aim in 2036 or 2046, according to the various countries, you will have to reduce by 85% the global potential in CO2 equivalent for all the aviation emissions and production and consumption. So 85% it's a lot, but I'm convinced that afterwards you will have a target for 90%, 95%, and so on.
Thank you.
Okay, thanks.
And the last question, because we need to go to next speaker. Please pay attention, Vanessa. The last question from Zahid Rehman. Sorry, from Samer Holman.
Okay. So yes, with the technical and supply complexity of the cold chain, where geographically are the 300 experts located to be able to practically support countries which need, like reducing food waste equals less hungry people?
I understand it. Well, all our experts are experts in our member countries. I mean, all our member countries, it is one of the advantages to be a member country, it is to propose experts. We have a selection of the experts, but they shall be people in our member countries. However, we also have sometimes to help non-member countries, and perhaps in member countries, you don't have enough experts in these kinds of fields. It's perfectly okay. It is often the case in some developing countries, even member countries, we don't have these experts. So we try to have teams. For instance, currently we have a project with the World Bank in Bangladesh. Bangladesh is not a member country. So we found people, experts in the cold chain in the United Kingdom. And we found some people in universities in Bangladesh. So we have a team between, well, the head office in Paris, some people in universities in United Kingdom, some people in Bangladesh, which are working together. And for instance, in Bangladesh, they are in charge of the identification of the needs. And so they have to propose some things, but it is checked by people in the United Kingdom. So we try to adapt our projects according to the people who are experts in the country and in other countries if necessary.
Great.
Thank you
Thanks.
very much for your presentation and answers.
Yes, thanks to the audience for great questions. It's a pity we can't answer all of them. And thanks for being active. So, and thanks for your presentation, Didier. So we can head to our next presentation. Our next speaker is Volker Stamer. Please, I give the word to you.
Okay, thank you so much, Vanessa. And to all of you for organizing this event. It's a pleasure to be here. Thanks for having me on World Refrigeration Day 2021, which is a matter of my heart, actually, that I can tell you a little bit about our solutions for commercial refrigeration today. That's the topic that Sergey pointed out. And our planet, as Didier was mentioning, with almost 8 billion people, wouldn't be able to work and function without refrigeration. And as you also mentioned, we could solve the hunger problem and many other problems with our industry. So when I was asked to do a presentation, I was thinking about what are our top solutions right now. And I was first thinking about our very flexible, efficient, and reliable scope of reciprocating compressor, which are repairable, overhaulable, and very sustainable. When you think about circular economy, repairability will be a major role in the future, but also the flexibility to adapt to various refrigerants is an important topic. But then another product came to my mind, and I thought about why not mentioning our new 8-cylinder CO2 compressor, which is really moving now into also industrial refrigeration field. Or should I talk about Ecolite, our new condensing unit, which is also A2L ready and helps, as Didier was mentioning, on the way to the natural refrigerants. Or should I mention Varipack, our new inverter technology, inverter who speaks refrigeration language? Or our new lines of heat exchangers would be also a possibility. Or about our BITZER digital network that gives you all around view on your BITZER compressors. Should I mention the new software tools that we have, like the CO2 tool included now, or the refrigerant ruler app? And I decided to do none of them, actually. My presentation is about all the people who made that. My presentation is about cool careers in our industry, because it's all about people and it is all done by people. And we need more people in our industry. There is studies telling us that the need for refrigeration air conditioning will triple by the year 2050. And we cannot move on like we did it in the past. We need to be more sustainable. We need to be more efficient. We need to be more smart and clever how we do it. The World Refrigeration Day is a perfect opportunity, and I really thank to establish this day on 26th of June. And the topic of this year is Cooling Champions, Cool Careers for a Better World. And I wanted to have something similar to that. And my topic of my presentation is Cool Careers and a Bright Future, which I definitely foresee in sustainable cooling. And we need people to get there. Why do we need that? Why do we need to get active? As Didier was mentioning, right now we are in a really, when you look at the news, there are not a lot of actually good news. There are a lot of bad news. The health situation, uncertainty, we don't know what's coming up in the near future. Also, what kind of refrigerant should we use and what not? So we need, from time to time, what does it do, these bad news, to us people? Does it make us active? Do we like to get up in the morning and yeah, we do it? I don't think so. Therefore, I thought I bring today some good news. If you look at this smiley, you see, and you look straight into the eyes, you see that these are not eyeballs, that actually these are pictures from the NASA, from the ozone layer left in the year 2000, when most countries decided to step out of fluorochlorinated hydrocarbons. And on the right side in 2017, barely noticed NASA reported that the ozone hole is getting smaller, and if you would look at today's date, it's even smaller. So what is the good news there? And by the way, refrigeration industry had only a small part of it. The good news is that it's in our hands what we do with the planet. And it's not the doctors, it's not the lawyers who solve the issues, it's the refrigeration industry and the engineers who need to come up with creative and sustainable solutions. The question is just where to start. And I would like to mention here a TED talk that I've seen and that impressed me quite well. And there were top 100 things that you should do in order to reverse climate change. And the number one, I was really surprised to hear that. And number three are belonging to commercial refrigeration. The way we manage our refrigeration systems and to reduce food waste. Under the top 20 topics, there are many topics that are related to us. The way we refrigerate, the way we store, the way we culture our land, the way we use our forests and whatnot. And we need to do combined efforts and smart efforts in order to avoid further climate change. So what is the right strategy? There are always two strategies in life that you can apply. Number one is this one. Also, we see that during the COVID-19 pandemic situation, a lot of people said, I don't want to hear, I ignore it. I don't know if this is smart, actually. It might be that you overcome it, but I would suggest the best way to deal with problems and topics is to learn about it. The more you know, the smarter your decisions are. Get active and get out of there and really create a momentum of industrial people that help solving the issues of today's date. And that is one of the reasons why our former and belated owner, Peter Schaufler, created this building, the SCHAUFLER Academy. He foresaw that we will have a tremendous need of new people to our industry, but also that we need to increase our knowledge. The world is very complex right now. There is a lot of systems, like if you think about CO2, we are on the 6th generation. It's not very easy to understand everything. We need to adapt, we need to learn. And that's why we built this academy, in order to support the industry with training from our engineers about natural refrigerants, but also low GW refrigerants that we need on the way. Intelligent electronics to increase energy efficiency, because it doesn't help us a lot if we only use low GWP refrigerants. We need to focus as well on the energy efficiency, and to also inform about current legislation. We offer product seminars, so all the products that you saw in the beginning of my presentation will be covered in trainings for sure. And this 15-20 minutes that I have here wouldn't be enough to mention even one of them. We offer also training courses for German vocational school teachers, but we plan to face it globally. And we cooperate very closely with university, academies, and other institutions, like also schools. We try to attract young people to get in our industry. I came to the industry as a mechanical engineer. No idea, usually all my colleagues, they went to the car industry, and I had a great professor. I loved thermodynamics, and he showed me a way, a path that I never even thought about it. And I can tell you the virus in refrigeration is more contagious than any other mutant that is on the planet. If you start a career here, you end the career usually as well. Last but not least, we also train our own people. So every employee of BITZER, even if they work in finance department, they get a crash course in refrigeration. They need to know how a refrigeration circuit works. For the industry, what we offer right now is the focus on natural and low GW refrigerants, always in combination with efficiency. So we have here a CO2 subcritical and transcritical plant. We have an ammonia container with 1.6 megawatts, so a real industrial system right next to the building. We offer hydrocarbon trainings, also how to enlarge envelopes, but also capacities of existing plants. And last but not least, we show also a way how to retrofit the many, many systems that are still out there and that need to be changed and replaced. Furthermore, what we do to the public, we started this year in January, we started an initiative to reach out to the public, to tell the public about refrigeration. And we did a webinar with quite great success. We had more than 400 people in this webinar, and I show you just quickly the teaser. We had a lot of interest to this webinar, and therefore we were motivated to do an English version, and we will announce it probably most likely in fall. And in this webinar, we basically showed the relevance and the important applications of refrigeration and air conditioning, that it actually starts before our life begins with the cooling of sperm banks, and it ends even if we are dying, our bodies are usually cooled as well. And in between, from birth to the deathbed, there is refrigeration all over the place, and we show it quite in our webinar quite successfully. Furthermore, we support young people. So the local schools around BITZER here in Germany, this little young fellow, he invented something which is really great on Arduino base, refrigerant loss device for smaller commercial refrigeration circuits. And he won the first prize here at Jugendforscht, which is an initiative of the government in Germany. We also support students with augmented reality. So we try to get a little bit of fresh approach with regards to our industry, basically to use cutaway models to explain technology a little bit further into detail. Augmented reality offers there a lot of opportunities to show how refrigeration works, how a compressor works, and other stuff. And you can also show all the details like economizing and these kind of things and take the compressor apart. A great invention done by also students here in Germany is this, the Bavarian breakfast heat pump, where the students wanted to remove the heat from the warm beer and basically boil sausage. So you can get a Bavarian breakfast, as you can see here, with a isobutane high temperature heat pump, very successfully made. So you see the potential, the creative potential of young students is immense. And we need to attract more people to our industry. That's why we offer here in the SCHAUFLER Academy all the webinars free of charge for students or for people who are in education. Furthermore, I want to also spoil here a little bit, do a spoiler alert. The prize that you will get for the most interesting question is this refrigeration handbook, the fundamentals of refrigeration, which is not only giving you insight into refrigeration business, but also translation, German on the left side, English on the right side. We are working on other languages as well. So this is available, and this would be the prize for the most interesting question today. And this book is in the meanwhile also available in ebook, different formats, like Apple Bookstore or Amazon. You can order it online if you wish. Other cool things is that we support the World Refrigeration Day, which is a great initiative, and it's in honor to the birthday of William Thomson, the first Baron Kelvin, who we thankfully have the temperature scale. Happy Refrigeration Day. We are a great supporter of these initiatives, and we hope that this succeeded in the future even more and interest not only people in our industry, but also outside our industry. That's all from my side. Thanks for listening today. And there is now room for questions. This is, by the way, where I'm presenting here, the SCHAUFLER Academy. Thanks for listening.
Great, thank you very much. Amazing presentation.
Thank you. Yes, very interesting. With video, great.
Thank you. Okay. Are there any questions in the chat room, or I can also
Yes, we have first question very long. I'm not sure. Please, Vanessa, read Yuri from Yuri's Solak.
From
Last question.
last question. Okay. So BITZER is offering liquid receivers. Very often installers select oversized receiver and charge 80% of its volume with refrigerant, and very often system is much overcharged. This may have negative impact on environment because of huge quantity of refrigerant used. So the question, do you have clear recommendations about the correct selection of receiver volume based on the total system capacity at specific conditions and based on internal volume of the system? So any recommendations?
Yeah, I'm not sure if you used our selection software in order to do that. For sure, that's on the safe side. If you have doubts, always, this is something what offers BITZER all the time. We have no call centers. We have actually real application engineers sitting here in Germany just waiting for your questions in case you have doubts about your system or how to do or apply the needs. For sure, the software covers is always on the safe side, for sure. But if you have doubts, then just send an email to us. You can share mine or at academy@bitzer.de, and we will forward it accordingly to our application engineers in case you have doubts. But the first tool to use would be our software. So if you select your system, you can select the liquid receiver in the software as well. There are rules of thumb, but most answer in our industry is it depends. It depends on many factors. And therefore, it's always worth to look at the entire system in order to optimize it. And in order to do that, definitely knowledge is needed, and we offer that in form of either specific trainings to our software tool, or also that you reach out to our application engineers who are highly trained. Okay? I hope that answered the question.
Great, thanks.
One moment. Next question from Samir Holman. Over the many years of working with young ones, what do you see as a key personal characteristic which we have?
Sorry, I didn't get the last.
Please repeat, Vanessa.
Yes. So, over the many years of working with young ones, what do you see as the key personal characteristic which they have?
Curiosity, absolutely curiosity. That's the key issue, and the will to not to give up very easily. Like the young fellow I showed in the picture, he's amazing. He's programming Arduino, but now he's so interested in refrigeration because he wants to make an impact. And he sees a lot of opportunity, and he's right now on the next project. He's doing the same platform as a Internet of Things, and we are also continuing with him. So I think what we need to do most, going to schools, I don't know how the situation is in other countries, but in Germany, there are not many experiments anymore at schools. So what thrilled me at my time at school were these experiments with liquid nitrogen and these kind of things, to get interest in these kind of things. And we do that now here in the academy. And also I know some universities like Karlsruhe, they send out the students to younger classes in order to attract young people to our industry. Most people, if you have no relatives or your father friend is in the industry, a lot of people are not aware that this is a very interesting field of business. So we need to spread out the word, and the best is really to go to young people. And for sure, they need certain knowledges. Math would help definitely if you go in this direction. But I believe the most characteristic is curiosity in technical topics, trying to understand how things work. That's how we select people, or this, in this case, this young scientist.
Great, thanks.
Okay.
Yes, I can see in the chat people are writing that they would like to train with you.
Okay, you're welcome. You find the trainings on our website. We actually did yesterday an ammonia training course, and next week we will continue with CO2. So there are webinars available. If you want to sign up, please do so. You're welcome. Okay.
Great. So, Sergey, do we have time for the last question?
Yes.
So
Please pay
help me to
attention.
choose.
Question from Mark Etienne Yan again.
Okay, great. So, what do you think the role of control technology will be in the future? Will controllers become more important for refrigeration installations?
Definitely. So I think even if we can still improve the efficiency on our side, like compressors or also heat exchangers, I think a lot of energy synergy lies in between communication, between Internet of Things like the BITZER digital network, to learn more, to not to overcharge, not to oversize, and these kind of things. And I think therefore we need more intelligence on the product, like our IQ products that will be continued definitely. So I foresee a lot more controller and interaction between controllers and to make smart decisions, but never forget the smartest part or piece in the entire refrigeration chain needs to be the people who design it and who program it. And we need those. That's why I mentioned it today very, very often and make it clear. We need more knowledge and more people. Thank you.
Great. Thanks.
Thank you very much.
So
Okay.
thank you very much. Yeah, for the great questions and for your great presentation. Shall we move to the next speaker? Sergey?
Yes, yes, please.
Yes. Okay, great. So now we are going to listen to Nikolay Koev. I give the word to you.
This Stamer, please turn off your screen.
Yes.
Thank you.
Thanks.
So, hello everyone. Vanessa, could you confirm that you can see my presentation? Okay, great.
You can, yeah.
So, hello everyone. Good morning to all participants from Europe and good afternoon to everybody connected from Asia. Welcome to Sanhua presentation. The topic is electronic expansion valve technology for refrigeration applications. My name is Nikolay Koev. I'm responsible for Sanhua sales and business development activities with OEMs and wholesalers in Central and Eastern Europe. And I also take care about Sanhua business development in food retail segment in the EMEA region. I will start with a short introduction of company Sanhua. It was established in 1984, so just 37 years ago. So we are a relatively young company on the markets, but for this short period of time, we managed to become a global leading supplier to 4 major industries. HVAC and refrigeration. We produce different components and controls for HVAC and refrigeration industry, and we are the biggest supplier of components to the AC industry. Just as an example, we produce more than 60 million pieces solenoid valves, four-way valves, which means that 70%, we have 70% market share in the world, and 2 out of 3 air conditioning units are equipped with Sanhua four-way valve. Next is home appliances. We produce many different components for home appliances, and we are the biggest supplier to the European OEMs, which produce different machines such as washing machines, laundry machines, tumble dryers, coffee machines, and home refrigerators. Our third division is production of microchannel heat exchangers. For the AC industry and again for the refrigeration industry, we have a very big product portfolio. We started the production of microchannel heat exchangers many years ago, and we developed this technology in last years. There is a clear benefit for the refrigeration systems and also for the air conditioning system because it can reduce the refrigerant charge up to 70%. We have a dedicated product portfolio for refrigeration and also for air conditioning. One of the fastest growing business also for us is the automotive industry. we produce and supply thermal management system to the manufacturers of electric vehicles. The thermal management system consists of different parts. One of them is responsible for cooling down the batteries of the electric cars. And also there is integrated heat pump for cooling and heating of the saloon of the car. Nowadays, our company has more than 23,000 employees, and in 2020 we achieved $4.1 billion turnover. We are not a typical Chinese company. We have a global presence with 15 production sites around the globe. We have factories in China, India, Mexico, US, and also in Europe, in Poland and Turkey. We have 37 sales companies worldwide. And since the establishment of the company, we have applied and registered more than 4,000 patents, which makes Sanhua one of the most innovative companies in China. Also, we were ranked among top 100 innovative companies for several consecutive years. With companies from different industries, from automotive, from electronics and computers. So we are one of these 100 companies, the most innovative companies in China. We are also sponsor of the World Refrigeration Day, which will be officially celebrated on 26th of June. We have a European team. We established Sanhua International Europe in 2008 to be more closer to our customers in Europe and to provide our services in time. We have technical and sales people in more or less each country, and we cover entire EMEA region, which means Europe, Turkey, Middle East, Russia, and also North Africa. There are several prerequisites for OEMs and distributors when they select a supplier. Definitely one of them is the quality and the reliability of the products, and I would say that Sanhua has proven its quality during the years with many OEMs and distributors. The second, of course, is the price of the components. Here we provide one of the best quality price ratio on the market. And the third and very important prerequisite is the availability of the goods. That's why we built our own warehouse in Poland, in South Poland. So just in a few days, we can supply our customers in the near region with components and controls. We keep variety of products on stock, such as thermostatic expansion valves, different sizes, different modifications, solenoid valves, line components, pressure switches, electronic expansion valves are available in our stock constantly. We analyze what is the market consumption, what is the demand, and we replenish our stock accordingly. The topic of today's presentation is our electronic expansion valve technology for refrigeration applications. Here, I would like to give you a little bit more information about our production, our global footprint. We produce more than 40 million pieces of different expansion devices and more than 30 million pieces of electronic expansion valves. We are the biggest supplier for the air conditioning industry, along with the four-way valves that I mentioned in the beginning. To produce such a big volume and to have the highest quality the products, you need a fully robotized and automated production. So from our production lines, in each 8 seconds, one electronic expansion valve is produced. We produce mainly, or I even would say only stepper motor electronic expansion valves. We have a very limited production of pulse wide modulation valves, because we believe that the future belongs to stepper motor valves, which are bringing some certain benefits for the refrigeration systems and for the users of refrigeration systems, such as much more precise regulation of the cooling process and the refrigerant flow to the evaporators, but also much more quieter operation, and there is no, let's say, much more stable operation of the system because there is no liquid hammer effect, which typically occurs in pulse wide modulation valves. Our product portfolio for refrigeration applications consists of two main platforms. Electronic expansion valves, both with stepper motor valves, LPF, LPFD, and DPFR. LPF was specifically developed for commercial refrigeration applications. It comes with a soft sealing design, which means that this valve represents a very high tightness, and when the valve is closed, there is no internal leakage to the evaporator, and there is no risk for the compressors. We have two models, LPF, LPFD. LPF is for 42 bar maximum operating pressure. It is suitable for, let's say, standard refrigerants, HFC, HFO refrigerants, but also for hydrocarbons. It is VD certified, so it can be used with flammable refrigerants. And LPFD is for maximum operating pressure 60 bar, so it can be used in subcritical CO2 installations. Regarding the cooling capacity, we have several sizes, so we can cover up to 26 kilowatts 449 and up to 27, 28 kilowatts cooling capacity in CO2 systems. Of course, it depends on the working conditions. Both electronic expansion valves, LPF, LPFD, and DPFR, both platforms has unipolar stepper motor with 500 steps. So actually, you can achieve a very precise regulation of the cooling process and the refrigerant flow to the evaporator. Our new valves, DPFR, are designed for CO2 application for transcritical systems with maximum operating pressure 140 bar. The cooling capacity is up to 35-36 kilowatts. In order to operate an electronic expansion valve, a certain controller is needed, and Sanhua developed some years ago its own superheat controller. This is the second generation on the left. It's X61 superheat controller. It comes with advanced PID algorithm for very precise regulation of the opening degree of the electronic expansion valve. There is 26 refrigerants in the database, so you can select from the very standard ones such as 404 or 134A, some mid-term refrigerants such as 448, 449, and the long-term refrigerants such as the refrigerants with very low GWP, 455A or 454C. Of course, propane, CO2, HFO refrigerants are also available. As a standard, there is a Modbus communication, so you can connect the superheat controller to a monitoring system and optimize the work of your refrigeration system. It's a plug-and-play solution, very easy to install and to set it up. On the bottom, you have 3 terminals to connect the EV coil with 5 pins, 2 pins to connect the temperature sensor, and 3 pins to connect the pressure sensor. And on the top, you have power supply, you have Modbus communication, you have alarms, and you have also run signal, so the controller can be connected to external thermostat case controller. It is compatible with Sanhua unipolar stepper motor valves, LPF and DPF. You have 4 modes: superheat control, positioner, manual operation, and it can be used also as for a hot gas bypass. It can be installed on a DIN rail, or it can be fixed also on a wall with screws. Another device is our VSD 2010 pin positioner. It's simple, let's say, driver. There is no superheat algorithm. So it can be used as a converter between, if you have, for example, controller for post-wide modulation valve, which is not able to drive stepper motor valve, but there is 0 to 10 volt signal output or 420 milliamperes. So this device can be used as a converter. So it receives the signal, let's say 0 to 10 volt, and converts the signal to some certain number of steps to the electronic expansion valve. But what is important to mention also that it comes with integrated ultracapacitor. It is a kind of a battery. So if there is, let's say, electricity failure, it will close the stepper motor valve completely, so there is no risk for the compressors. We have some accessories which can be used together with the SEC61 superheat controller, pressure and temperature sensors. We have different pressure ranges. So if you use our superheat controller and our electronic expansion valves with CO2, then you can select the appropriate pressure sensor, which is 090 bar. Or if you use standard refrigerants, you have different options. You have also solder or thread connection. For example, if you have a propane system, then you can select a suitable pressure sensor for propane. What we are offering else, it's the transformer, 230 volts to 24 volts. Actually, the controller SEC61 works with 24 volts, so you need a transformer. Additionally, as a separate device, we have the supercapacitor. So again, it's a kind of a battery. It can be connected to the controller, and in terms of electricity cutoff, it will close the stepper motor valve completely. We have also external display, which can be connected to the superheat controller. And if you have several units, it's not needed to make, let's say, settings to all of them. You can just make the settings on the first one, and then you can copy and transfer the parameters to the next ones. In order to facilitate the ordering process and the stock, let's say, management of our partners, we created so-called Sanhua electronic kit, which contains all EV parts needed for one evaporator. So you have in one box the controller, you have the pressure sensor and the cable, you have the electronic expansion valve and the coil, and you have also the temperature sensor. All these parts which must be connected on the bottom of the controller. We have several different sizes. We have different capacity. So if you would like to calculate the capacity, you can use our selection software, or you can use our selection tables in the data sheets. So you can select the appropriate size of the electronic expansion valve, and then you can select the right SEC kit. We have several models with inch connections, and we have several models with millimeter connections. So the only difference, the only different part in this box is actually the electronic expansion valve. So we have different sizes for different capacities. As I said in the beginning, you have 26 refrigerants in the database. Because here you're a little bit limited, you can use 19 of them. But as you can see, you have all new refrigerants and all, let's say, transitional refrigerants. The maximum operating pressure of this LPF is 42 bar. That's why you cannot use it with R32 or 14A, or let's say with CO2. Now I will give you some information how you can upgrade your refrigeration system using our electronic expansion valves and controllers. We can take as an example the most, let's say, conventional refrigeration system equipped with thermostatic case controller, a thermostatic expansion valve, and solenoid valve. We have many of these installations in Europe and actually across the globe. This is a system we can find in many supermarkets, hypermarkets, for cold rooms and cabinets. So there are several main questions when we're speaking about upgrades of conventional system thermostatic expansion valve with electronic expansion valve. First is it difficult to upgrade the system? Do you need some specific knowledge to do this? Is it costly, of course, and what are the benefits? So I would say that in terms of installation work, is not much more than connecting thermostatic expansion valve. Here you have to connect the thermostatic expansion valve, the sensing bulb, probably you have equalization line which must be connected to the suction line. You have also to install the solenoid valve and to wire the coil to the controller. So if you have to upgrade the system, I would say it's similar in terms of installation work. You need to install the electronic expansion valve and the coil. Again, here you have temperature and pressure sensor. you don't need solenoid valve. So you have a little bit more wiring. So all these parts must be connected to the superheat controller. And then you have several options. You have Modbus communication to link the controller to a monitoring system. You can connect also the supercapacitor if it's needed, but if the refrigeration system has some backup as diesel generator or whatever, you don't need the supercapacitor. And in some cases, you don't need the transformer if you have, for example, 24 volts from the thermostat case controller. So you keep the thermostat case controller, and instead of sending signal to the solenoid valve, it is just connected to the superheat controller, and it sends signal to the superheat controller. So in terms of installation work, it's not so, let's say, sophisticated in terms of additional knowledge. Yeah, you need a little bit more information regarding the wiring. And to set up the controller, actually, it's very easy because you have two main parameters. You have to select the refrigerant and you have to select the superheat. It can be 5, 6 kelvins or 7 kelvins. All other parameters are predefined, so no need to change them if it's not needed. What are the benefits using electronic expansion valve comparing to the thermostatic expansion valve? First, you know, this is to compare, for example, on-off compressor with inverter compressor. You have first much more stable operation of the system, much more precise regulation of the cooling process, and of course, the most important is that you can achieve a significant energy savings. Is it costly? I would say that we managed to balance the price for electronic expansion valve, temperature and pressure sensor and the controller to be similar to thermostatic expansion valve plus solenoid valve. Speaking about higher capacities, for example, cold rooms with high capacity than 16 kilowatts, I would say that this solution is even cheaper. But in any case, even for small capacities, having this significant energy savings, I would say that the period for return of the investment is very, very short. The next application that we see more and more, also in Europe, but also around the globe, are CO2 installations equipped with pulse-wide modulation valves and controller for pulse-wide modulation valves. I would say that the natural choice and the future, what we see also transition from thermostatic to pulse-wide modulation valves, and the next step will be stepper motor valves because of the much more precise work of the stepper motor valve. So if you want to upgrade your system with stepper motor electronic expansion valve, I would say it's also even more simple. You just need to connect the stepper motor valve instead of pulse-wide modulation valve, and you need our converter, this positioner VSE2010P with ultra capacitor connected to the main pulse EV controller. So you can use either 0 to 10 volt or 420 milliampere, and this signal is converted to some certain number of steps to the electronic expansion valve. And the research shows that actually you can achieve up to 10% energy savings just replacing pulse-wide modulation valves in refrigeration systems with stepper motor electronic expansion valves. On our website, you can find a lot of information. You can find our products, our data sheets and installation instructions. You can find also our selection software, and you can register for our newsletter, so you'll be up to date with all products that we launch on the market. Thank you very much for your attention, and if you have some questions, please let me know.
Thanks a lot.
Thank you very much. Yes, I can see a lot of questions. Sergey, please help me to choose.
One moment. First question from David Lenarduzzi. Hi, Nikolay. How important the Italian market is for Sanhua?
The answer is very easy. Each market is important for Sanhua. As I said in the beginning, we have technical and sales people, not only in Europe, but over the world. So we try to take care about all our customers. and to give them the best support. So on our website, this is something that I forgot to mention. On our website, you can find actually the contacts of my colleagues responsible for different countries, for different regions.
Thanks.
Great. Okay.
Vanessa, please pay attention. Question from Samir Holman.
Yes, I think it's an interesting question. So the question is, EEVs have been in the market for a few decades now, and definitely the advantages are clear. What do you think is the biggest challenge for greater market adoption of this technology? Samir says that his refrigeration experience is in the Middle East Africa since 2005.
Right, yeah, this technology is on the market for many years, and we have to admit that this technology, I mean, stepper motor valves, for example, it's not new for the air conditioning business, because the air conditioning business have been using stepper motor valves since decades, I don't know, since many years. But we saw in the refrigeration business that there was a transition from standard thermostatic expansion valves to post-wide modulation valves. And now we see also the transition from post to stepper motor valves. So for me, honestly speaking, it's a matter of time to see this technology on the market in refrigeration business. There were some obstacles that had to be overcome, but I would say that now we have all prerequisites to think that this technology will be well adopted in refrigeration systems very soon. We have the right solution. I think we have the right balance between quality, performance, and price. So we believe that we'll see more and more customers using stepper motor valve.
Great, thank you. So our next question is from a person with a very interesting name, Pier Francesco.
Yeah.
So electronic components are good to optimize refrigeration cycle, but sometimes in small refrigeration systems like small cabinets, refrigerators, etc., we find capillary tubes because they are cheaper, and so the system costs low but is not efficient. The question, will it be possible in the future to combine energy efficiency or small systems and costs?
I would say yes. We see that when there is a new technology on the market, of course, in the beginning, it's more costly. But we have many examples. We have examples with electric vehicles. We have examples with inverters. We have examples with EC fans, for example, on the condensers. But we see that moving to mass production and more customers, this technology is becoming more cheaper. And this is what will happen also with electronic expansion valve and controls for electronic expansion valves. And it's the other driver, of course, is local legislation. For example, in some countries, we see that the energy efficiency is the most important. So it doesn't matter that the customers, for example, the producers have the opportunity to produce a cabinet with capillary tube or with thermostatic expansion valve or with EEV. They will select the EEV. They will select the inverter compressor in order to produce the most efficient system. So it's a matter of, as I said, local legislation, but of course it's a matter of the developing of the technology, and we see that we already have a very good base because we produce more than 30 million pieces of electronic expansion valves per year. So I'm pretty sure the price will not be, let's say, comparable to capillary tube, but it will be optimized, and I think it will be acceptable from main producers of refrigeration units, plug-in refrigeration units also.
Okay, great. Thanks for answering. So now that we have listened to all the presentations, we can start our question and answer session. Yes, Sergey?
Yes.
Okay, so now you can ask your questions to any of the speakers. Please tell us which speaker you want to get an answer from.
I will ask my first question, okay? And then we will read the next questions. My question for all speakers about career opportunities. How to find a job in the refrigeration industry, for example, in Europe? What ways do you can recommend?
Sorry, in what exactly, or where?
What ways do you recommend for people to find the job in refrigeration industry, HVAC and our industry?
Who wants to start?
Who can answer? Your recommendation for people.
Yeah. Didier showed on the side of IAR or on other associations in our industry, member companies, and it's always worth to look and depending on the country, what jobs are currently available and in various companies. And to start, actually, I would recommend, this is the only thing I would change in my personal career, to start as a hands-on guide, because I think it's a very practical oriented business. I studied mechanical engineering, so I'm coming more from a theoretical point of view. I learned welding and these kind of things and brazing, but I think if you start with a practical approach, you're definitely not getting out of jobs, and you are, if you are good, like some people here in Germany that I talk to, they are traveling the entire world because there is a huge need for practical, a more practical approach, people, hands-on guys. Didier, you're muted. Sorry.
Yes, Didier, we can't hear you.
Yes.
Yeah, now we can.
I can complete the answer. Perhaps I didn't understand exactly what the person would like to know, but of course there are some possibilities to inform people that there are jobs. And for instance, in our website, we sometimes put some proposals for jobs because some of our members mention that. But it is a very small part of the possibilities. The possibilities are mostly at the national levels. And at the national levels, well, you have first companies, you have universities, but also you have various schools for engineers or technicians. It is difficult to have a general answer. I mean, the way the job, the employment system is deployed in depend on the country. So it is very difficult to have a general answer for that. But in any case, the problem is not only the fact that, well, as far as I know, perhaps there are some countries where it is not the case, but as far as I know, all the people who are who are in the school for technicians or engineers in the refrigeration field, they find jobs. And the problem is to attract people in these specialized training at universities, at schools, dedicated to refrigeration. There are not so many, country by country, not so many which are very specialized in that. And the problem is that they have some difficulties in a lot of countries to attract these people in these trainings. And it is, for me, the main issue is to inform people at schools, to incite people to, and for instance, we built an exhibition in Paris, then it moved to Korea, then to Switzerland, in order to explain to everybody, people who don't know what refrigeration is, to show to people the various kinds of uses, including with including with playing some with various tools, in order to understand what refrigeration is. But regarding jobs themselves, I think it is at national levels.
Great, thanks for your answers. So we have a next question. It's from Surab Yadav. This is a question for Volker Stamer. What role does SCHAUFLER Academy play for young engineers to start a job in the HVAC and R industry?
Oh, very interesting and good question. Thanks for this. Actually, what we don't do is we don't do cover the fundamentals. Only for our own people, we do fundamentals of refrigeration. So there are a lot of institutions that we cooperate with in order to give you a start on your career, how to learn about all the things about refrigeration. But our approach is that we have always latest technology on board, and we don't have permanently hired trainers. We have trainers from application engineering. So the idea behind the SCHAUFLER Academy is that we do trainings always up to date. So when I hire a trainer at today's date, his knowledge in 3 years will be 3 years old. That doesn't matter in thermodynamics or in fundamentals of refrigeration. But if you think about CO2 or ammonia, where the trend is right now in low charge ammonia systems, we need always fresh knowledge. So what I can recommend, the Kelten Club, actually, I also can recommend, there's in the chat, if you are in Germany, there are several institutions that help you also to get in touch with older engineers. And I think the networking through associations like IAR or in Germany, DKV, that's highly recommended, that you learn, that you create a network, that you learn from experienced guys. I think this is the best learning curve. And that's also a place what we try to have when COVID-19 is over. When you have a live and presence training, that you meet people from other industries to learn from each other, but also here in the SCHAUFLER Academy. What we currently offer is, as I mentioned, free of charge trainings, webinars for people in education. And that's, you can join there too, if you wish. For sure, we have 3,800 people, but we cannot offer everybody a job. That's clear. But I think the industry needs definitely a lot more, and we can accompany you not only with products, but also with training on the products and on the applications like natural refrigerants, for instance. I hope that answered the question.
Great, thanks. So the next question is from Ungani Piri. It's for all the speakers. So some countries are still using refrigerants that have a high ozone depleting potential. What are you doing to help it completely phasing out such refrigerants?
May I answer? Of course, the other ones can complete. You must know that in any case, CFCs are already forbidden, banned in all the countries. Sometimes with chlorofluorocarbons, we have some problems, and we had recently a problem with China, where there was still a production of CFCs. Because we discovered it, what I mean, we, not the IA itself, but we discovered that there were some emissions in the atmosphere of these it was, I think, CFC 11. So in that, of course, in that case, because of this discovery from institutions which are in charge of examining the components of the atmosphere, the stratosphere, and so on, there were some discussions with the government of China, and normally now we found the reason, and these emissions were stopped. So in any case, there are some controls of the emissions which help us to check that we respect the Montreal Protocol. Now, we have, regarding the ozone layer, we have HCFCs, hydrochlorofluorocarbons. Their ozone depletion potential is much lower than CFCs. So in any case, even if we didn't have to phase out HCFCs, the situation would be much better thanks to the end of the CFCs. But regarding HCFCs, we still have the possibilities in developing countries to use HCFCs until 2030. Okay, in 2030 that will be forbidden, and we will have to check the emissions to check if there is no problem. For instance, we have banks of CFCs or HCFCs still in operation, but of course it is important for us, and there are some programs in some countries to be sure that we will destroy these banks at the end. Regarding HCFCs, of course, there are some programs at the United Nations level, the United Nations Environmental Program, to help countries to progressively phase out HCFCs, and if possible, to replace them by low global warming refrigerants, not with high GWP HFCs. And one of the main challenges we currently have is to avoid moving to high GWP HFCs when phasing out HCFCs, because now the main target is climate change. Much more important now than the ozone layer. The ozone layer is recovering, so be optimistic regarding the ozone layer. The case of the stratospheric ozone layer is almost finished.
Great. Thanks.
Maybe I can add something. If you learn about thermodynamics, there is a conservation of energy that everybody knows about. But there's one energy form that is unbelievable, highly available. That's the criminal energy of people sometimes. And I think this is not always done like refrigeration, smuggling, and illegal and fake refrigerants that are going on right now. I would say the best thing is to teach those people who do that, to learn them and teach them the impact, and also make them aware and create more awareness. And this is what we try to do with training, to learn about all the topics and these kind of things. And worst case is really that you basically tell government or like Didier was mentioning, institutions who take care about that there is an illegal or a refrigerant still used that shouldn't be. So there is no observance of in some cases, yes, but I think we need to be also applied to our common sense, in my opinion, and learn about it. It's like some people didn't take care of COVID-19, ignored it, and there are always people like that, I guess. Yeah.
Great, thanks. So we have another question from Surab Yadav. It's for Nikolay this time. Do you have EEVs for vapor absorption systems? The select of these kind of valves seems difficult.
Thank you for the question. I have to address this question to our technical managers and probably to our R&D. So we need to check. I'm not quite sure if we have a standard solution, but what I can say that Sanhua is a very open-minded company. So depends on the situation, depends on the business case, we can customize and we can produce different kinds of products for different applications. We've been working with many big OEMs, and actually we produce many different components which are not standards. They are for specific application, for specific working conditions. So it's how to say, we're open to customize and to work on every interesting new projects.
Great.
So you can send the inquiry directly to us, and we can review.
Great, thanks. I can see a very interesting question from Pier Francesco. It's from BITZER and IR. So training is very important, above all for technicians working in service sector of refrigeration systems. They must ensure the refrigeration system works efficiently during entire life of systems. So there is a need to have good trainers for them. So the question is, who trains the trainers? Is there a necessity to have official, possibly public schools able to prepare good trainers?
May I answer first, and of course, Volker can continue that. I would like to mention that there are some programs to train the trainers, and we ourselves worked several times with the United Nations Environmental Program in order to organize training for trainers especially in Africa and South Asia, and in various languages too. I mean, we cannot only use English for that. And so we have some programs with the United Nations Development Program. There were programs on site, partially on site, partially online. Of course, the latest ones were totally online because of the COVID, but generally partially on site, partially online. In addition, we ourselves have on our website and in websites of our partners some trainings for trainers, and we were part of a European project, especially Relatives for Life, which was dedicated to that. Especially, the aim was especially to train people regarding low global warming refrigerants because of safety issues, in order to use these refrigerants as well as possible. So there are programs for that, but perhaps Volker can complete that. Sure. I'm sure that BITZER also has its own programs for that.
Yeah, I would also say it also depends here. If you talk about fundamental topics or also more applied topics, we train, our trainers are permanently trained also by our customers or by field issues. And what we are doing here in Germany, at least, and we want to spread that out, that we teach vocational school trainers. We have a really lack of vocational school trainers in Germany. There are 120,000 school teachers currently teaching in Germany, and in the next 5 years, more than half of them will retire. So they are fairly old, and they still used, when they were active, the R22 and other topics. So some of them, they don't see the need to change to natural refrigerants, for instance, and learn about it. And that's why our foundation supports the teacher education on natural refrigerants. We need to do that, because if the teacher doesn't know it or teach it, the students will not. So we need to continue this a little bit, and to start more pushing towards natural refrigerants, that you have to deal with flammability, like hydrocarbons, that you have to deal with high pressures like on CO2, and with toxicity with ammonia. And if you have covered these three, I would say you're very, very well trained and prepared for the future, in combination, for an instance, also with topics like energy efficiency. And I see another question which goes in a similar direction. People with 20+ years, that's exactly the target group that we are targeting to, because my personal experience, I never stopped learning, and I will never stop learning. Even if I'm 54 years old, I every day learn new stuff and new things. And I think keeping the curiosity that I said, it's a good start at career. Keep it up and open, and then you are well prepared to make the right choices and the right decisions for your future and the future of our kids and grandkids.
Okay,
Thanks.
that's great. Yeah, thanks. You have already answered Peter's questions. Thank you very much. So we have another question from Siju Thomas Matthew from India. The question is for Volker Stamer again. Which type is best suited for refrigeration compressors application? Frequency inverters, VFD, or soft starters, and how to select? Is it considering on load?
Correct. The question is, I can answer it by that we offer all of that, and not out of fun or to confuse you, just to give you the options to make the right decisions. It really depends on your part load profile that you work on. So sometimes mechanical unloading, and also on the availability of technology, but also on knowledge as well. If you're not feeling comfortable with frequency inverters and have no clue about it, I wouldn't apply it. That's why we offer trainings on that. It depends on your load profile for sure, whether you go mechanical unloading, VFD, and also on the VFD side, there are several options in the BITZER world, that you have an external VFD in the control panel, or one directly built to the compressor. There are many, many things to take into consideration to make the right decision for your project. If you have doubts or concerns, always, once again, you can talk to real life persons here at BITZER our application engineers in order to make the right choice and the right decision. There is no single answer. If you would ask me what is the refrigerant of the future, there is no single one that will cover it. What is the future of capacity regulation? There are many possibilities, and I think, like always in life or also with us people, diversity makes it not only interesting but gives you the right choice.
Great.
I answered it. I'm not
Great.
sure. Otherwise, we can also give the email address out. So I saw many questions actually in the chat. So maybe we can also get the email address and write them back. I'm not sure if that's possible or
yeah,
not that
maybe.
somebody gets no answer. That would be a pity.
Yes, we definitely have a lot of questions.
Yeah, that's good.
Yeah, I think we will choose last question from Peter Chitando.
About retraining.
Yes.
I think Stamer has already answered this question about about retraining if he's been working in the field for 20+ years.
Okay, I think that's enough. We can finish our question and answer session. And now we are going to draw a prize for most interesting questions. Please help
yes.
Nikolay
Please, dear
and
speakers,
Volker. Choose the winners.
Yes, which questions did you think were the most interesting? And I'm going to remind that our first prize is from BITZER. It's Volker Stamer's book, Fundamentals of Refrigeration. And the second prize is from Sanhua.
That's
Please.
really hard. All good, very good questions actually. But
it's difficult to choose.
What I would, to be honest, I liked, even if it's nothing to do with trainings, but I liked the question concerning liquid receivers and that people think about the system, because I think system approach is the key to solve a lot of issues, and making out of components a perfect system. I like that very much. So therefore I would pick the question from, oh, I cannot read the name actually. I don't know how to open it. From Yuli Solyak, concerning the liquid receivers that installers very much oversize receivers. So if you can give us your address, we will send you the book, or we can send also you, Sergey, the book. I'm not sure if it's where you're located, but for sure it would be my pleasure to give you our handbook. It was a very well formulated and large question, and I think it approached a good thing. So this would be my selection for the book.
Great, great, thanks. Yes, so please, dear winner, contact your information.
Sorry, Vanessa, did you write the name of the winner?
I remember it was Yuri.
Yuri Solak.
Yes.
Right?
Yes.
I think, yes.
Yuri Solak.
So congratulations and have fun with the book.
Congratulations.
Yes, congratulations.
Okay, Nikolay, please choose your winner.
Okay, so I have to select from the ones, the people who actually ask the questions, or from all people who address their questions in the chat.
You can read the chat and maybe find
choose
question.
any question. Yes.
Okay, I got two interesting questions from Samir Holdman regarding what do you think is the biggest challenge for greater market adoption of this technology, of the EV technology, and from Pier Francesco Fantoni regarding the implementation of EV in small capacity systems. So the winner will be Pier Francesco Fantoni for his question, yeah. And So I can inform you regarding the gift after the session. So we need to check, and I will give you exact information what will be the price.
The winner
Great.
is Pier Francesco Fantoni, right?
Yes.
Yes,
Right.
yes, yes. Our congratulations to Pier Francesco. I saw he asked a lot of questions. Actually, he was very active.
Okay, so we chose the right person.
Thank you very
Yeah.
much. And now I will ask take part in the next the poll, please. Look on your screen. How likely are you to recommend our next event to a friend or colleague? Where 10 is extremely likely, 1 not at all likely.
We can see a lot of good answers. Thank you.
Okay, thank you very much. Please look at the result. I think it's good result. Thank you.
Yeah, great result. Thank you very much.
Thank you for your assessment. And finally, please don't forget to register and subscribe to the newsletter Refrigeration Daily News. Please look in the chat how to do it.
Yes, you can see all information in the chat. And we are very grateful to our dear speakers and listeners for taking part in this webinar. It was a great experience. Thank you very much for your wonderful presentations. We were very happy to see you.
Thanks
Thank you
for
very
having
much.
me, and thanks for organizing. Very well done. And I'm a subscriber of your channel already, and I can recommend
Thank you very much.
definitely. Thank you. Keep up the good work. All right.
That's great feedback. Thank you very
Okay.
much.
Thank you very much. It was a
Thank you
pleasure.
very much for the organization.
All the best. Stay healthy.
Thanks. Yes, that's a good wish. Stay healthy.
Yeah. Take care.
Bye.
Bye.
Bye bye to everyone.